Good morning, everyone. Good morning. Good morning. Welcome to this lecture series on group theory, symmetry operators. Good morning, everyone. Good morning, Megha, Riti. Let's wait for the others to join, and until then, let me just introduce what we are going to discuss in today's class. We are going to discuss symmetry operator properties. Okay, we discussed 5 different symmetry operators in yesterday's class, and they were proper rotation, reflection, then you have improper rotation, inversion, and identity. Okay, so 5 different symmetry operators, and what we are going to do is we are going to look at what the different properties of these symmetry operators are, or when these symmetry operators operate on a molecule or an atom or any object which is at a certain position, how do they change their coordinates. Okay, so these are the 2 things that we are going to look at, and these are questions that have appeared in the CSIR net exam multiple times. Okay, so what are the different what does a symmetry operator do to a particular atomic coordinate xyz, and also what does a symmetry operator do to an entire molecule. Okay, so for example, these calculations are going to be useful later on when we discuss the internal coordinate method, or what we call as the where we rather than internal coordinate, the Cartesian coordinate method, where we use the transformation of atomic coordinates in order to calculate the number of unshifted atoms. Okay, whichever atoms are unshifted, they help us calculate the reducible representation of a molecule, and that's where what we are going to learn today is very, very useful. Okay, good morning, Komal. Good morning. So in this lecture series, in this week rather, what we are going to see is various types of symmetry operators, then properties of these symmetry operators. That is something that we are going to discuss in today's class, and later on from tomorrow's class, we are going to discuss what point groups are, what low symmetry point groups are, and high symmetry point groups are. Okay, so these are very, very important and critical examples when it comes to the CSIR net exam, because these are questions or these are examples that are asked repeatedly in the exams. Okay, good morning, Vagaram. Good morning, good morning. Okay, so now before we proceed, I'd like to request all of you to share the link of this video. If you have not liked it, do like it once you watch the video, but make sure that you share this video with all of your friends, especially those who struggle with physical chemistry, especially those who think that physical chemistry is a subject for people who had maths or people who understand physics and whatnot. Physical chemistry is a subject for everyone. Anyone who tries to study physical chemistry, or especially group theory, will end up understanding group theory. So, and they'll also end up scoring very well on group theory questions in the CSIR net exam. Even 4-mark questions they'll be able to solve. So that's the main point, that's the main intention of teaching this subject to all of you. Okay, and we are going to, as you all know, that the medium for this entire lecture series is in English. So those who struggle with Hindi, understanding concepts in Hindi, for them this lecture series is going to be a big boon. Okay, so we'll join here every day at 9 o'clock in the morning, and we'll study various concepts of group theory. Okay, so now what are we going to study in this session? We are going to study 2 different aspects. One is transformation of atomic coordinates. If there is an atom present at coordinates x, y, z, and if I apply any particular symmetry operator to that atomic position, what we will end up getting, or what does x, y, z turn into, that is something that is what we are going to see in this class. Okay, and then later on we are going to have a look at the powers of various atomic coordinates, various symmetry operators. For example, what will happen if I rotate a molecule twice? Okay, so if there is a C3 rotation, that's a 120-degree rotation. What will happen if I rotate it twice? What will happen if I rotate it thrice? Okay, or what if I take a reflection of a molecule 3 times? Okay, so these sorts of questions we are going to answer with products and powers of symmetry operators. Okay, so it's going to be a very interesting class that way, because you will see a lot of mathematics here, but you will also realize that you are understanding the mathematics. Okay, those who are comfortable with math, no issues, but those who are afraid of physical chemistry because there is a lot of math, you'll notice that the math that you see here, you'll understand it very quickly. Okay, so that's what our aim is, because the math that we are going to do here, I am going to explain it as if I am explaining it to a 5th standard student. So anyone who did not have math will also understand it very well. Okay, so there were 5 different symmetry operations that we studied. One was proper rotation, which is there is an axis of symmetry or line of symmetry, and you rotate the entire molecule or all the atoms around that particular axis. Then you have reflection, which is a plane of symmetry. Okay, then you have improper rotation, which is SN. Now proper rotation was rotation around an axis. Reflection was a perpendicular reflection around a plane. Okay, now improper rotation is a combination of the two. Improper rotation has a line of symmetry. There is an axis of symmetry around which a molecule rotates, and then there is also a perpendicular plane of symmetry around which the molecule gets reflected. Okay, rather across which the molecule gets reflected. Okay, so that is improper rotation. Okay, then you have inversion. Inversion is sort of, you can say, reflection through a center of symmetry. All right, and finally you have identity. Identity simply means doing nothing. Okay, identity means simply doing nothing. Okay, now have a look at proper rotation. Proper rotation is written as Cn. Cn means n-fold rotation. Okay, so it means that to get back to the original position, how many times do you have to rotate? Okay, that is the value of n. Or in other words, in a 360-degree rotation, how many times would you observe an equivalent configuration? Okay, so that is what is proper rotation. That's what proper rotation means. Okay, now the angle of rotation theta is given by 360 degrees divided by n, where n is the number of equivalent configurations that you get in a complete 360-degree rotation. Okay, now if you apply this 360-degree rotation, suppose we are talking about a 2-fold rotation, which means we are talking about the C2 rotation. By 2-fold rotation, what we are talking about is the C2 rotation. And suppose there is a atom here, its coordinates are x, y and z. Okay, its coordinates are x, y and z. So along the xy axis as well as along the z axis, these are its coordinates. Okay, so if you have an atom present at coordinates x, y, z, and if you rotate it along certain axis, what sort of coordinates do you get? That is what this particular point is about. So Cartesian system meaning the xyz plane or the xyz coordinates, and in this, suppose I take these xyz coordinates and I apply a rotation C2 around the z axis. I apply the rotation C2 around the z axis. So what's going to happen now? This xyz molecule is going to rotate. When it is C2, what it means is it's a 180-degree rotation. Okay, it's going to rotate by 180 degrees and it will point in a direction where, now notice that when you rotate something, okay, suppose you are standing and you start rotating, okay, does your height change? No, your height does not change. Okay, so if I assume that this is the z axis, okay, if I assume that this is the z axis and if I start rotating, my height is not going to change, and my height means the z coordinate. So if I am rotating around the z axis, my z coordinate will not change. Okay, which means in my answer, the z coordinate is going to remain as it is. Okay, x and y might change, but the z coordinate is going to remain exactly as it is. Okay, and now as a result, how will you think about what happens to the x and y axis? For the x and y axis, think of it this way. Because z coordinate does not change, now let's look at just x and y axis. Okay, you have a point here, x and y coordinates are given, and you want to do 180-degree rotation, which means this point is now going to go here, and if this was x and this was y, this up to here, from the origin up to here is x, then to the left it's going to become minus x, and just like that, if above was plus y, below will become minus y. So the coordinates of this point become minus x and minus y. Coordinates of this point become minus x and minus y, and you get minus x and minus y here. Okay, and you get minus x and minus y here. So if you have a point at coordinates x, y and z, and if you perform a 180-degree rotation around the z axis, the z coordinate does not change, z remains as it is, but the x and y coordinates, both of them change their sign. Whatever their sign was, the sign will become opposite of it. Okay, so that is twofold rotation, that is C2 rotation. Okay, now another thing that we'll notice whenever we look at this is, which coordinate does not change its sign? The coordinate that appears in the symmetry operator. Whichever axis you rotate the point along, okay, whichever axis you rotate the atom around, that coordinate does not change. What that means is, suppose I take the same position x, y, z, and if we perform a C2 rotation around the x-axis, what do you think we'll get? Because it's a rotation around x-axis, the x coordinate remains the same, but y and z coordinates will change their sign. Okay, because it is a rotation around the x-axis, the x coordinate will remain the same, but y and z coordinates will change their signs, and you will get x minus y and minus z. Okay, x minus y and minus z. Is that clear to all of you? So then, suppose, try this now, x, y, z is rotated around the y axis. X, y, z is rotated around the y axis. What will you get? What will be the answer here? If the atom at position x, y, z is rotated around the y axis, what do you think we will get? Can someone tell me? So notice how when we rotated around x-axis, x coordinate did not change sign. So when we rotate around y-axis, what do you think will happen? Very good, Megha. Minus x, then you will have y, and then you will have minus z. Okay, minus x, then you will have y, then you will have minus z. Okay, so this is proper rotation in the Cartesian system. Okay, all right. Now, before we proceed, I'd like to remind all of you that all the students who are preparing for the June 2024 CSIR DET exam, CSIR DET, June 2024. For all of you, we have a recorded batch in English. We have a test series in English. And we also have a lecture series in English. Okay, we have a recorded course, purely in English, where all the lectures are in English, all the notes are obviously in English. We also have a test series that is entirely in English. We also have a lecture series for organic chemistry, inorganic chemistry, physical chemistry, and aptitude entirely in English. So those who are aiming at this CSIR Net June 2024, make sure that you make complete use of this one benefit that IFAS is giving you, which is a flat 30% discount. It's a flat 30% discount. Use the promo code IFAS30. Okay, it's a flat 30% discount. Use the promo code IFAS30 and register for any of these courses and start your preparation on time with India's best educators. Okay, these courses are going to be game changers. They are specially designed for you to crack the CSIR Net exam. Okay, and not just crack it with a top rank. Crack it with a top rank. Okay. Now, the next point that we want to see is reflection. Okay. What would you get if you reflect reflect around a particular plane? Now, just like when we were talking about rotation around an axis, the axis consisted of one coordinate. Okay, let's say it was C2x or C2y or C2z. But if you are talking about reflection, in reflection, you have to have two different coordinates at least. For example, this is sigma xz plane. Okay, it consists of the x-axis as well as the y-axis. Okay, in the same way, this one particular plane, which is a plane made up of the x-axis and the y-axis, this will be sigma xy. Okay, this will be sigma xy. Okay, in the same way, if you look at this particular plane, this consists of the y and the z axis. So this will be sigma yz. Okay, this will be sigma yz. Is this clear to all of you? So whenever we are talking about an axis of rotation, it was a rotation around one particular axis, either x or y or z. When we are talking about reflection, it will be reflection across a plane consisting of two different axes at a time, either xy or yz or xz. Okay, and the same trick that we applied when we were talking about rotation around a particular axis, you can apply the same trick when we are reflecting across a particular plane. So for example, if I take an atom present at x, y and z coordinates, and suppose I apply the reflection operator around the xy planes. If we apply the reflection operator around the xy planes, what do you think we'll get? Now the same rule applies, which means if you have x and y coordinates here, the coefficients of x and y will remain unchanged. Okay, what that means is you will get x here, you will get y here, and the z becomes minus z. Whichever variable is absent here, that variable will change its sign. Very good, Megha. Very good, Megha, Komal. Absolutely. X, y and minus z. Okay. So imagine that you have a plane like this. XY plane is this horizontal plane. So imagine a plane. If you have put something on top here and if you're reflecting it around this plane, it will just change its z sign from positive z to negative z. And which is why x and y remain exactly where they were. Z changes its sign. Okay, very good, Megha and Komal. Now, the same way, can you tell me what will happen if XYZ, an atom at XYZ, is reflected around the YZ plane? Atom at XYZ is reflected around the YZ plane. What will happen if an atom at XYZ coordinates is reflected around the YZ Z plane. Good morning, Anurag. Good morning. How are you, Anurag? Okay, so can someone tell me what will happen here? Can someone tell me what will happen here? If an atom at x, y, z coordinates is reflected around the yz plane, what do you think we'll get? We will get minus x, y and z. Very good. What we will get is minus x, y and z, and the reason is because you have y and z here, the coordinates of y and z will not change. Because you have y and z here, the coordinates of y and z will not change. Okay, and that's the simple reason why you will get minus x, y and z. And similarly, if you apply sigma xz, because you have x and z here, their signs will not change, but you will get a minus y here. Okay, because you have x and z, their signs will not change, but you will get, the y will get converted to minus y. Okay, the y will get converted to minus y. Okay, very good. Megha, Anurag, Komal, absolutely correct. Absolutely correct. After attending your class, I am absolutely confident for exam. Very good, Anurag. Very good. Very good. Confidence is key. Confidence is absolutely important for cracking the CSIR net exam. What you study is just secondary. But after you study, if you are getting the confidence that you will be able to solve questions in the exam, that is most important. Okay. Everything else you can just revise and you can just remember. Later on, you can practice more and you can get better at solving problems quickly. But the main point is that you should develop a confidence that you will be able to crack each and every question in the exam. All right. Okay, great. Now the next point is improper rotation. Okay, the next type of let's say Bega is asking for Raman activity questions. Yes, they will come. Raman activity, IR activity questions will be later, but we have to learn what character tables are first. So we are going to discuss those also. All right. Okay. Now how about improper rotation? How about improper rotation? Okay. Now improper rotation, Sn, or let's say S2, will be C2 multiplied by a horizontal plane of symmetry. Okay, it will be C2 multiplied by a horizontal plane of symmetry. So for example, if we are talking about S2 around the Z axis, you will have a C2 rotation around Z axis. Okay, you will have a C2 rotation around Z axis, but you will have a reflection around a plane that is perpendicular to Z axis. Okay, so now suppose this is the Z axis. Which plane is going to be perpendicular to it? It's going to be this plane. Okay, this is the plane that is going to be perpendicular to the Z axis. Okay, which means C2Z will, after applying C2Z, we have to reflect around the plane that is perpendicular to Z, that is X and Y. Okay, and here knowing this itself will give you a trick. Okay, knowing this itself will give you a trick. C2Z will change signs of X and Y. Sigma XY will change sign of Z, which means each of these operators, S2Z, S2Y, S2X, will change sign of all X, Y and Z. What that means is XYZ will be converted to minus X minus Y minus Z. So for example, let's start with XYZ and let's apply C2Z first. When you apply C2Z, the sign of Z will remain the same, but the signs of X and Y change. Okay, and when you apply sigma XY, then what will happen is the signs of X and Y remain the same, the sign of Z changes. Okay, which means simply XYZ is converted to minus X minus Y minus Z. All three of them change their sign when you are applying S2Z. Okay, and the same thing you will see when you apply S to X or S to Y. The axis around which improper rotation is taking place does not matter. You will end up getting minus X, minus Y, minus Z every time. All three of them have to change their sign. Okay, X, Y, Z rotated around the S2 Y axis will also give minus X, minus Y, minus Z. Okay. E identity product formed. Okay, I don't know what that means, Megha. I agree that E is the identity. I don't know what product form means. Sir, do you cover all the topics for CSIR net exam in this lecture series? Yes, absolutely. We are going to cover all the topics for CSIR net in this lecture series, that too entirely in English. Okay. We are starting with group theory, but we are going to try to cover each and every topic entirely in English. Okay. All right. Okay, so this was improper rotation. Remember that. So just like S to Z is C to Z into sigma xy, you also have to remember, suppose, so for example, if I write S to X, what will this be? This will be C2 rotation around the X axis, but then multiply this by sigma YZ plane, then multiplied by sigma YZ plane. Identity product formed in improper rotation? No, identity is not formed in improper rotation. Okay, identity is not formed in improper rotation. Okay, improper rotation is rotation followed by perpendicular reflection. So identity means XYZ would remain XYZ. Here XYZ is changing to minus X, minus Y, minus Z. So it's not an identity operator. Okay, it is not an identity operator. Okay, similarly, S to Y is C to Y into sigma XZ. Okay, is that clear? Now, I think, Megha, what you are confusing with is the improper rotation or at least the two-fold improper rotation. Okay, this is only two-fold improper rotation. So, this is only true for whatever we have solved is only true for two-fold improper rotation. Three-fold, four-fold, meaning S3, S4, S5, they give completely different answers. But when you have S2, you always get minus X, minus Y, minus Z. Okay. Now, suppose we are looking at inversion and identity. Okay. What we know is inversion leads to, so suppose you have a point here, X, Y, and Z. Inversion through origin would mean that this point is reflected here and it ends up being there. When the point goes there, all the X, Y, and Z coordinates are interchanged. When the point goes there, when it is inverted through the center of symmetry, each and every point X, Y, and Z are inverted. Their signs are inverted, which means for inversion, X, Y, Z will give minus X, minus Y, minus Z, as it is a reflection through the origin. The reflection of plus X is minus X, the reflection of plus Y is minus Y, the reflection of plus Z is minus Z. Okay, and as a result, you will simply get minus X, minus Y, and minus Z. Okay, is that clear to everyone? Is that clear now, Megha? So what you were talking about is inversion being equal to S2. Okay, S2 also gave minus X, minus Y, minus Z. Inversion also gives minus X, minus Y, minus Z, which means that S2 and inversion, both of them have to be exactly the same. Okay, S2 and inversion, both of them have to be exactly the same. Okay, so this is what is called as inversion. Okay, whereas if you have identity, identity means changing nothing, keeping everything the same, which means here also you will get X, y and z. Okay, identity will not change the signs of x or y or z. All of their signs will remain exactly the same as they were earlier. Okay. So these are the 5 symmetry operations and the way they transform atomic coordinates. Okay. Now based on this, what types of questions do you get? This was a question that appeared in June 2014. This was a question that appeared in June 2014. So the result of the product C2x into C2y. Okay. The result of the product C2x and C2y is what? Okay. Which means what we have to do is one after the other. We have to first apply C2x, then apply C2y. Let's try that. Start with XYZ coordinates. First apply C2x. Start with XYZ coordinates. First apply C2x and what will C2x give you? Komal, Megha, Anurag, Nandini. What will C2x give you? Remember, if you have an x coordinate there, what that means is, if it is a rotation around C2 x axis, it means x coordinate will remain unchanged, y and z will change their sign. X coordinate will remain unchanged, y and z will change their sign. Very good, Komal, very good, Megha. X minus y and minus z. Now the next part is tricky. What if we apply C2y? What if we apply C2y? Now the y coordinate is not going to change its sign. Okay, but x and y, x and z will change its sign. Now x is positive here, so x becomes negative. The sign of y remains as it is. The sign of y remains as it is. And the sign of z also changes. Okay, a lot of students confuse here. A lot of students get confused here because they think that the sign becomes negative. No, it doesn't become negative. If the sign was positive, then it becomes negative. If the sign is negative, it can also become positive. Okay, so here x will become minus x, but minus z will become plus z. So whenever you're changing the sign, remember that it's not becoming negative, it is saying we are changing the sign. Okay, and now if you look at the starting position and the ending position, you will notice that the z coordinate has retained its sign, but x and y have changed its sign. When does that happen? Suppose I want to go directly from here to here. Suppose I want to go directly from here to here. How do which operator will leave the sign of z unchanged, but will change the signs of x and y? Which operator will change the sign of x and y, but will leave the sign of z unchanged? Very good, Komal. It will be the C2z operator. And if you don't realize what operator this should be, just look at which variable sign is not changing. Z's sign is not changing, which means we will write z here. And after that, what we will do is, if you just have one variable, which type of operator does it have to be? If you have two variables, we know that it is the reflection operator. But if you have just one variable, it means that there is rotation around only one axis. So this has to be C2. This has to be C2, and which is why the third option is going to be the correct answer. Very good, Komal and Nandini and Megha, absolutely correct. Okay, so C2x into C2y is C2z. Okay, C2x multiplied by C2y is going to give you C2z. Okay, good morning, Prakash. Good morning. Is this clear to all of you? Is this clear to all of you? Does anyone have any doubts here? Okay. Before we proceed, I'd like to remind you that preparation for any exam cannot take place nicely, systematically, without good reference books, without good study material. And IFAS is the best study material in India. I know because I myself have written it. I myself have made these books along with the entire IFAS team, and you will not get better books than these. You will not need to study 25 different reference books, because all the important points that are covered in each of those reference books are already there in these books. These books are made with a specific goal of CSIR net exams, or GATE exams and SET exams. All right. So if you are preparing for any of these exams, either CSIR NET or GATE or SET or government exams like BARC or ONGC or NTPC or even TIFR entrance exams, these books are a must for all of you. Okay. And you're getting these books at a flat 50% off. Use the promo code BOOK50. This offer is valid till the 31st of December. And you will end up getting the entire study material set, which is a set of 13 books at a discounted price, a flat 50% discounted price of 5,250 only. All right. So do not miss this chance of getting the best study material at such a price. Okay. Now let's look at powers of these symmetry operators. Okay, we have had a look at a lot of different symmetry operators, how they transform various atomic coordinates. Now let's look at powers. Okay, Cn raised to n. Okay, so for example, C3 cube. What does this mean? C3 cube means C3 into C3 into C3. Okay, C3 cube means C3 into C3 into C3. Now what does C3 mean? C3 means a 120 degree rotation, which means performing C3 3 times will be the same as performing 120 degree rotation 3 times. And that would give you a total of 360 degree rotation. That will give you a total rotation of 360 degrees. Okay, and a 360 degree rotation simply means an identical configuration. So what you will end up getting is E. Okay, a 360 degree rotation means simply E. Okay, and which is why Cn raised to n is always equal to identity. Cn raised to n is always equal to identity. Okay. Now, when you are talking about sigma, okay, taking powers of reflections, sigma raised to n has a unique property. It will either be E or it will be sigma itself. When will it be E? If n is an even number, then you will get E. But if n is an odd number, you will get sigma. For example, sigma cube is sigma, sigma raised to 4 is E, sigma raised to 5 is sigma, and so on. Okay, so whenever you have an odd number power of sigma, you will get sigma itself. Whenever you have even number power of sigma, you will get E. Okay, and this is something that you might know from your visits to shopping malls. Okay, when you go and visit a shopping mall, you will see that wherever if you buy clothes and if you go to the changing room has 3 mirrors, right? One here, and one here. Okay, so you will have mirrors that look like this. You will have mirrors that look like this, and you are standing here. Okay, now when you look at the mirror right in the front, what you see, so suppose you are like this, you will see a reflection. Okay, if you are standing right in front of a mirror, you will see a reflection of yourself, which means your coordinates are inverted. Left becomes right, right becomes left. But if you are standing like this, okay, what will happen is you will see yourself exactly as you were earlier. Okay, you will see yourself exactly as you were earlier. Okay, so there is no change, there is no reflection. Like for example, you won't see left becoming right and right becoming left. You will see yourself exactly as you were. Okay, and which is why the changing rooms have mirrors that have multiple mirrors. So when there is a reflection, from two different mirrors, whenever there is a reflection from two different mirrors, then or these are mirrors which are actually perpendicular to each other, then you will not get reflected. You will see yourself as you originally are. But if there is reflection only along one mirror, you will see opposite, left becoming right, right becoming left. Have all of you noticed this? Have all of you noticed this? Okay, so in shopping mall mirrors, you will see this happening. Okay, and the same logic applies here. So when you have sigma square, if you take reflection twice, you end up looking at exactly as you were earlier. But if you take sigma once or thrice or 5 times, you will actually see a reflection. Okay, is that clear? Anurag, Komal, Megha, Prakash, Nandini. Is that clear? Have all of you seen this happen in shopping malls? Okay. Okay, good. All right. Now, how about inversion? How about inversion? Inversion also gives you either identity or inversion itself. If n is even, you will get identity. If n is odd, you will get inversion. If n is even, you will get identity. If n is odd, you will get inversion back. Okay, you will get inversion back. Okay, is this clear? Now, suppose you want Sn raised to n also. Okay, just a second, let me change this quickly. This is supposed to be Sn raised to n. Okay, how about Sn raised to n? Sn raised to n gives something very interesting, something completely different as compared to everyone else. Sn raised to n is e. Again, if n is even, but Sn raised to n is sigma if n is odd. Okay, Sn raised to n is e if n is even, but Sn raised to n is sigma if n is odd. Okay, what are some examples of this? S2 squared is e, but S3 cubed. Okay, remember it's not S2, it's S2 square, but S3 not raised to square. It's S3 cube. Okay, this number and this power. Okay, the order of rotation and the power, they have to be the same. S3 cube is not e, it is sigma. Okay, S3 cube is not e, it is sigma. Okay, is that clear? Let's try a few more examples. Cn inverse. What is the inverse of proper rotation? This can be written as Cn raised to n minus 1. Okay, for example, C4 inverse is C4 cubed. Okay, what you have to do is take this 4, take this minus 1, add them up. 4 minus 1 is 3, write 3 here. Okay, if you want C5 inverse, take 5, take minus 1, add them up. 5 minus 1 is 4, so this will be C5 raised to 4. This will be C5 raised to 4. Okay, now what do you mean by inverse? Remember that any operator A multiplied by its inverse will give you E. Okay, any operator A multiplied by its inverse will give you E. Okay, product of an operator and its inverse is identity. Product of an operator and its inverse is identity. Okay, is that clear to all of you? So what that means is, if you multiply C4 and C4 cube, okay, so therefore C4 multiplied by C4 cube must be identity, and you know that that is true because C4 multiplied by C4 cube is going to be C4 raised to 4, and what have we just seen? C4 raised to 4 is going to be identity. C4 raised to 4 is going to be identity. Okay, So the inverse of improper rotation is Cn raised to n minus 1. Okay. The same way, what is the inverse of reflection? The inverse of reflection is reflection itself. Okay, because reflection multiplied by reflection is identity. Sigma square was identity. So sigma inverse is sigma itself. Similarly, inverse of inversion is also inversion itself. Inverse of inversion is also inversion itself. Okay, and about Sn. Improper rotation has two different versions of inverses. This is Sn raised to n minus 1 if n is even, but it is Sn raised to 2n minus 1 if n is odd. Okay, so remember this very carefully. Examples of this are S4 inverse is S4 cube. S4 inverse is S4 cube, but S5 inverse is not S5 raised to 4. This is S5 raised to 9. What we have to do is n, the value of n is 5. 5 into 2 minus 1. 2n minus 1 is 2 into 5 minus 1, which is 9. So this will be S5 raised to 9. Okay, remember this for improper rotations. Okay, remember this for improper rotations. Okay, is this clear to all of you? Is this clear to all of you? Yes, Komal, Anurag, Megha, Nandini. Who else is here? Prakash. And Preeti and Vagaram are very silent ever since they have joined. Is this clear to all of you? Is this clear to all of you? Okay. Now let's look at something interesting. Each operator will have powers of its own. Okay, so for example, you have C3. But you can also have C3 squared. And you can also have C3 cubed. Okay, you can also have C3 squared and C3 cubed. Now C3 will remain as CT. It's just a proper rotation. But C3 square, we have seen that this simply becomes C3 inverse. Okay, look at this. What is Cn inverse? It's Cn raised to n minus 1. So if you have C3, what is the inverse of C3? 3 minus 1 is 2. You will get C3 squared. Similarly, C3 cubed can also be written as E. C3 cubed can also be written as E. So powers of C3 are C3, C3 inverse and E. Okay. Similarly, if you look at powers of C4, you have C4, C4 squared, C4 cubed and C4 raised to 4. Okay. Now if you have these powers, okay, if you have these powers, we can figure out what each of them are. C4 is C4. What will C4 square be? Now look at this. C4 squared is essentially C4 multiplied by C4. Okay, and what do you mean by C4? What should be the angle of rotation if we are operating C4? If we are using four-fold rotation, C4 rotation, what should be the angle of rotation? Can someone tell me? What should be the angle of rotation? Can someone tell me? Yes, very good. The angle of rotation should be 90 degrees. The angle of rotation should be 90 degrees. And C4 twice means we are performing a 90 degree rotation twice. Okay, which means it's a total of 180 degree rotation. And when do you get a 180 degree rotation? Which operator gives you a 180 degree rotation? Okay, Nandini is asking, explain sigma again. Nandini, watch yesterday's class. In yesterday's class, we have discussed what sigma is, which is reflection is, or watch the beginning of today's class. Okay, you can watch, you can just rewind and you can watch the beginning of today's class where we have talked about reflection. Okay, so which operator gives a 180 degree rotation? Very good, Komal, a C2 axis. Okay, so which means this C4 square can be written as C2. Okay, this C4 square can be written as C2. Can someone tell me what C4 cubed will be written as? Can someone tell me how you can write C4 cubed? How do you write C4 cubed? Can someone tell me how we write C4 cubed? C4 cubed will be 120 degrees? No, not really. C4 is 90 degree rotation. 90 degree rotation thrice will become a 270 degree rotation. So no, we are not talking about C3. We are talking about C4 applied thrice. Now again, let's go back to this. Look at this. What is C4 cubed? C4 cubed is C4 inverse. C4 cubed is C4 inverse. So you can write C4 inverse here. What you can do is you can write C4 inverse here. Okay, is that clear? And then what is C4 raised to 4? What is C4 raised to 4? C4 raised to 4 is identity. C4 raised to 4 is simply identity. Is that clear to all of you? Is that clear to all of you? Is that clear to all of you? Okay. Now the same way, let's look at powers of C6. C6, C6 squared, C6 cubed, C6 raised to 4, C6 raised to 5, C6 raised to 6. Quite confused? Okay, Komal, which part is confusing you? Komal, which part is confusing you? Komal, which part is confusing you? Good morning, Surabhi. Good morning. How are you, Surabhi? So, Komal, which part is confusing? Which part is confusing? Is C4 cube confusing you? Is C4 cube confusing you? Power of C4. Okay, which part? Which part in power of C4? Which power of C4? Like the C4 raised to 1, C4 raised to 2, 3, 4. If all of you have to learn to ask better questions, precise questions, don't just say power of C4. Tell me which power of C4. Is it C4 cubed? Is it C4 raised to 4? What is it? Okay, now let me explain C4 cubed. C4 square we have solved here. Okay, C2 is a 180 degree rotation. What will C4 cube become? C4 cube is simply C4 inverse, right? Okay, see what we have written here. C4 inverse, any inverse of Cn, what you have to do is take this n, take the minus 1 and write n minus 1 here. So when we are talking about C4 inverse, take this 4, take this minus 1, write C4 raised to 4 minus 1, which is C4 cubed. So this C4 cubed is simply going to be C4 inverse. If you actually multiply C4 3 times, what you are going to get is C4 multiplied by C4 multiplied by C4, which is 90 degrees plus 90 degrees plus 90 degrees, which is going to be a total of 270 degrees. And a 270 degree rotation is not a proper rotation axis. It's not a simple proper rotation axis. 270 degree rotation. So suppose we have a molecule here. C4 rotation will take that molecule here. But what will C4 inverse do? C4 inverse will rotate it in exactly the opposite direction. Okay, C4 inverse rotates it in the exactly opposite direction. Okay, now if you look at this, this is a overall 90 degree rotation. Okay, but if you take a total of this rotation, if you take this entire angle, that angle is a 270 degree rotation. 90 plus 90 plus 90, 270. And notice that in order to take the molecule M from here to here, in order to take the molecule from here to here, you can either do a C4 inverse rotation or you can do a 270 degree rotation and arrive here, which means C4 cubed is the same as C4 inverse. Is this concept clear now, Komal? Is this concept clear now? Yes, Komal, is this concept clear now? Yes? Okay, great. Great. So then let's look at powers of C6. Can someone tell me? So C6 remains C6. What is C6 square going to become? What is C6 square going to become? C6 square is C6 multiplied by C6. C6 square is C6 multiplied by C6. Okay, and C6 means what is the angle of rotation? If we are talking about C6, what is the angle of rotation that we are talking about? If we are talking about C6, what is the angle of rotation that we are talking about? Can someone tell me? Megha, Surbhi, Nandini, Anurag, Komal, 60 degrees. Okay, so this is a 60-degree angle plus a 60-degree angle, which means a total of 120 degrees. Now, a 120-degree rotation means which rotation? A 120-degree rotation means what type of rotation? A 120-degree rotation means what type of rotation? C3 rotation, absolutely correct. Which means C6 square can also be written as C3. Okay, C6 square can also be written as C3. Okay, is that clear? Is that clear? Then how about C6 cube? Then how about C6 cube? Can someone tell me? Make the same calculation. Do the same calculation. C6 cubed is C6 multiplied by C6 multiplied by C6. That's 60 degrees plus 60 degrees plus 60 degrees. That will give you 180 degrees. So can someone tell me what C6 cube is going to be? Can someone tell me what C6 cube is going to be? Yes, 180 degrees, C2. Very good, Komal. This is going to be C2. Is Komal the only one who is paying attention? Where is Megha, Surbhi, Nandini, Anurag? Are you here? Or have you dozed off? Are you paying attention? I think it's only Komal who is paying attention. Where are the others? Where are the others? Okay. Then how about C6 raised to 4? Now C6 raised to 4 is interesting. C6 raised to 4 can be written as C6 square ka square. Okay, it can be written as C6 square squared. Okay, C6 raised to 4 can be written as C6 squared squared. And what is C6 squared? That is C3. So this will be C3 squared. Okay, C6 raised to 4 will be C3 squared. Okay, for example, we can always write this is because x raised to 4 can be written as square of x square. Okay, square of x square is x raised to 4. The same way, C6 raised to 4 can be written as the square of C6 square. Okay, and you will get C3 square. Now, what is C3 square equal to? What is C3 square equal to? Look at this. C3 square is equal to C3 raised to minus 1. C3 square is equal to C3 raised to minus 1. Which means C6 raised to 4 is nothing but C3 raised to minus 1. Okay, C6 raised to 4 is nothing but C3 raised to minus 1. Okay, is this clear to all of you? Is this clear to all of you? Similarly, C6 raised to 5. Now, C6 raised to 5 we can figure out. C6 raised to 5 is essentially C6 raised to 6 minus 1. C6 raised to 6 minus 1. And which means this has to be C6 inverse. Okay, this has to be C6 inverse. Okay, so this will give you C6 inverse. And finally, C6 raised to 6 is going to give you identity as usual. Okay, this is going to give you identity as usual. Okay, is this clear? So do we understand what different powers of C3, C4 and C5 are? Okay, now the same way, let's have a look at powers of improper rotations. So you will have S3 squared. Okay, S3 will remain S3. We have to figure out what is S3 squared and S3 cubed. Okay, we have to find out what S3 squared is and S3 cubed is. Okay, now let's look at S3 squared. What is S3? S3 is C3 multiplied by sigma. So S3 squared will be C3 squared multiplied by sigma square. Okay, S3 square will be C3 square multiplied by sigma square. Now what is sigma square? Sigma square is E, and C3 square is essentially C3 inverse. Okay, so S3 square is not S3 inverse, it is C3 inverse. S3 square is not S3 inverse, it is C3 inverse, and that's exactly what we had seen. What is the inverse of improper rotation? If n is an odd number, it is Sn raised to 2n minus 1. Okay, so S3 square is not S3 inverse, it is C3 inverse. Okay, and now similarly, what is S3 cubed? Similarly, what is S3 cubed? S3 cubed, S3 is C3 into sigma. So S3 cubed will be C3 cubed into sigma cube. Now what is C3 cubed? C3 cubed is identity. What is sigma cubed? This is sigma, which means S3 raised to 3 is going to be sigma. Okay, S3 raised to 3 is going to be sigma and not identity. Okay, is that clear to all of you? Is that clear to all of you? Now the same way, let's look at powers of S4. S4 will remain as it is. What is S4 squared going to be? What is S4 squared going to be? S4 is C4 into sigma. So their square will be C4 square into sigma square. What is C4 square? We have just seen some time back. What is the square of C4? Square of C4 is C2. So there we can write C2. Here we can write C2. And sigma square is identity. So S4 square will actually end up giving you C2. S4 square will actually end up giving you C2. How about S4 cubed? Now because it's an even number, 4 is an even number, the inverse of an improper rotation with an even number symmetry is S4 raised to 4 minus 1, meaning S4 raised to 3. So S4 raised to 3 will be S4 inverse. Okay, S4 raised to 3 will be S4 inverse. And finally, what is S4 raised to 4? Because 4 is an even number, this will be identity itself. Make a note of all of these. Very, very important. Make a note of all of these. Very, very important. Anu is worried about when the admit card will come. Admit card will come after the 20th of December. So don't even wait for it right now. There are 10 more days. Admit card will most likely come 10 days later. Okay, admit card will come 10 days later. So don't even think about it right now. Only worry about what your preparation should be. Okay. Anu? Alright, now let's look at powers of S6 then. So powers of S6 are going to be even further complicated. So S6 will remain as it is. S6 squared. Can we solve this? Yes. This can be written as C6 squared into sigma squared. What is C6 squared? C6 squared is C3. We saw it just some time back. C6 squared is C3 and sigma squared is E, which means S6 squared is the same as C3. S6 squared is the same as C3. How about S6 cubed? S6 cubed will be C6 cubed into sigma cubed. C6 cube is C2. Sigma cube is sigma, meaning Now, what is C2 multiplied by sigma? Remember, rotation multiplied by reflection. Okay, remember rotation multiplied by reflection. C2 multiplied by sigma, that is S2. C2 multiplied by sigma, that is S2. And you get an inversion. S2 is the same as inversion. So S6 cubed is the same as inversion. The same way, what is S6 raised to 4? This will be C6 raised to 4 multiply. All right. Okay. And finally, S6 raised to 5 will be, what will S6 raised to 5 give? This will be C6 raised to 5. C6 raised to 5 multiplied by sigma raised to 5. What is C6 raised to 5? C6 raised to 5 is C6 inverse. Sigma raised to 5 is sigma itself, which means this will be S6 inverse. And that is exactly what we expected, because S6 has the order of symmetry as 6, which is an even number. Its inverse is going to be the 5th power, 6 minus 1th power. So you will get S6 inverse. And then what is S6 raised to 6? We don't even need to solve this. This is going to give us identity directly. Okay, this is going to give us identity directly. Okay, so these are the powers of improper rotation as well. Okay, so what we are going to get is C3 inversion, C3 inverse, S6 inverse, E, and the original S6 as it is. Okay, so these are the powers of S6. Is this clear? Komal, Anurag, Anu, Megha, Surabhi, Nandini. Is this clear to all of you? Okay, so then let's solve a question that appeared in the exam. The product of C2x into sigma xy. Well, actually this question you can just solve based on this thing. So x, y, z. First apply C2x. First apply C2x. So that gives you x minus y and minus z. Then if you apply sigma xy, signs of x and y remain the same. You will get x and minus y here, and the sign of z has to change, so you will get plus z here. And now notice that there are two variables, x and z, which have retained their sign. If two variables have to retain their sign, then you will get a reflection operator. Okay, then you will get a reflection. Okay, so take a screenshot of this question, and I want you to post the answer in the comments after this session. Okay, this is a homework question. So what you have to do is you have to evaluate S4 squared sigma xy okay. I think we were buffering for some time. Okay, all right. So this question is for homework. Just evaluate these four. I think we have already evaluated all of them. So the first one, S4 square, you know what the answer is. The third one, S4 cubed, and the fourth one, S6 cubed. You already know the answers to them. So you can tell whether the first, third and fourth are correct. For the second one, use XYZ. First apply sigma xy, then apply sigma yz and check what you get. That will give you which of these is correct. Okay. And this is another question that is for homework. Both these questions are for homework. Okay. The equivalent symmetry operations of S6 cube and S3 raised to 6 are. Okay. S6 cube and S3 raised to 6 are what? Okay, make sure that you take a screenshot of this as well as a screenshot of this. Okay, take a screenshot of this question. Okay, so you have to evaluate these four, tell us which of them is correct, and also take a screenshot of this question. This was this appeared last year, February 2022 exam, and this is very important for all of you. Okay, Anurag is saying, sir, I am your biggest fan. Sir, I really love to attend your classes. I have a request to you. Please give priority to teach batch of 11th September. Please, it's my humble request. Sure, absolutely. Why not? I'd love to teach the 11th September batch also. I'll ensure that I'll teach a topic in that batch. Okay? Rest assured, Anurag. Don't worry. Okay. All right. So let's stop today's session here. Remember that so this session is for students who are typically trying for the June 2024 CSIR NET exam. Those who are trying also for the December 2023 exam, we have an exclusive test series for CSIR NET December 2023. And because the exam is this month itself, this test series will have a duration of 1 month, and the price has been slashed to 500 rupees only. Okay, the original price was 2000, we have reduced it to 500. So make sure that you enroll in this course for practice. Okay, Komal is asking point group. Point group is in tomorrow's class. Today's class we were looking at symmetry operators. Remember the title of today's class? It was symmetry operators. Okay, so I want all of you to be a part of these 1000 plus IFASians who qualified in the last CSIR NET exam, the June 2023 exam. I want all of your names to be here. Okay, and in order to do that, what you have to do is you have to register on our website, and you can access a lot of free study material there. And there are free previous year question papers. You can download them as a PDF format and solve them. And you will also get PDFs to this particular lecture series there. In the next class, in the upcoming class, I'll come up with a stepwise method where I'll tell you where you can get PDFs of all these classes. Okay, so make sure that you have registered on the IFAS app. All right, and thank you for paying attention, but I want more participation. I think today only two or three students were participating. Komal was there and maybe Megha was there for some time, but I want others also to participate every day in the class. Anurag, Annu, then we have Surabhi, Megha, Nandini. Okay, I want all of you to participate in the class. Prakash. Okay, because it's okay if you give wrong answers. No one is going to judge you for giving wrong answers. But if you don't try, then you are not going to get your answers. If you have to try, you have to fail sometimes. Remember when you learn to ride a bicycle, you must have fallen 3 or 4 times. Fall 3 or 4 times. It's necessary in your learning process, because if you don't fall, if you stop learning the bicycle from the fear of falling down, then you will never learn the bicycle. So just participate. It's okay if your answer is wrong once in a while. I'm sure that the answers won't be wrong as many times as you are afraid of. You will be giving right answers, but don't be afraid of giving wrong answers. Here in the exam, of course, we have to be afraid because there is negative marking there, but here you do not have to be afraid of giving wrong answers. Okay, so thank you for attending this class. Make sure that you tell your friends about this lecture series. We are going to cover the entire syllabus in English. Okay, so until our next class, which is tomorrow at 9 o'clock, goodbye and happy learning.